Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at this problem, and this is from section 4.3, and it says determine the intervals on which the function is concave up or concave down, and identify the inflection points. So think about a curve here, something that goes up and down, something that is smooth, so it's continuous, it's differentiable, and concave down means like it's a bowl that is upside down, and at some point called the inflection point it changes from concave down to concave up, and then it's concave up like the bowl is up, and then at some point here at another inflection point it changes from concave up back to concave down. And that's what we're looking for. We're looking for the inflection points, and then we need to check if the second derivative is positive in that interval, then that means it's concave up, and if the second derivative is negative in that interval, it means that it's concave down. Let's go ahead and take a look at this one. And the first thing I always like to do is to put this into the calculator. So go to y equals, put the function in, and then let's do a zoom standard to start with, see what this thing looks like. It doesn't give me a real good idea, so let's do a zoom fit. Oops, and that looks a little bit better. So as you can see, it looks like it's concave down right until about here, and then it becomes concave up all the way until about here, and then it looks like it's changing back to concave down. So those are around x values of -5 and +5, so that's what I'm going to be looking for when I check the second derivative. Now when I check the second derivative and I set that equal to 0, that will let me find the inflection points, and then I'll check the intervals. Let's go ahead and get started here. So I'm going to rewrite this as negative e to the -1 over 50 x squared. Just makes it a little bit easier for me when I apply the power rule and chain rule and all that good stuff. So now finding the first derivative here, I am going to take the derivative of the outside function. So that's just going to be the same here. So negative e to the -1 over 50 x squared times, and then applying the chain rule, I have to take the derivative of this inside function. That's where you bring the 2. And so that will be times -2 over 50, which becomes 1 over 25 x. And then putting those together, I am going to get, this is going to be equal, the negatives cancel out, and I'll have e to the -1 over 50 x squared, and I'll take this x here, bring it there, and bring the 25 and put it down here. So this is the first derivative right here. That's x e to the -1/50 x squared all over 25 when I simplify that. Now I'm going to apply the product rule in order to solve this next one. So let's first rewrite this. I'm going to rewrite this as x over, actually, a little bit easier to write it like this. So 1 over 25x times, and then I can multiply that by e to the -1 over 50 x squared. All right, so let's apply the product rule. So f double prime of x, the second derivative, that's going to be the first, so that's going to be 1 over 25x times the derivative of this, so that's going to be times, make sure I got this right, e to the -1 over 50 x squared, right, times the derivative of that, so times this right here, that would be -1 over 25x, like this. So the first times the derivative of the second plus the second term. So that's going to be e to the negative 1 over 50x squared times the derivative of the first, which is just 1 over 25. So this is how I set that up. And then I'm going to need to clean that up a little bit here. So 25 times 25 is 625, and that's a negative. So this is going to be equal to, okay, so that's negative e to the negative 1 over 50x squared. And we have an x there as well. So that's going to be an x all over 25 times 25, which is 625. And I actually have an x and an x there, so that's going to be x squared. And then, so this is negative, should make that a little bit better of a negative there. So combining all this, I get negative x squared from the x and the x, e to the negative 1/50th x squared there, all over 25 times 25, which is 625. And then we're going to have this one right here, and that's going to be plus, and that'll be a little bit easier, e to the negative 1 over 50x squared all over 25, like this. And then I can multiply this by 25 over 25 to get a common denominator. So this will be, and I'll separate, or I'll switch these around too, so I have the positive and then the negative. So this will be 25 e to the negative 1 over 50x squared all over 625. That's this term here, just multiplying a 25 over a 25. And then we'll have a minus x squared e to the negative 1 over 50x squared all over 625. And then we're going to combine that. So it's going to be, and I'm going to also pull out the e to the negative 1/50x squared, and that's going to leave me with, I think, 25 minus x squared. So 25 minus x squared all over 625. 25. All right, so here is the second derivative. And it's a lot of work, I know. But now we're going to set that equal to 0. So e to the negative 1 over 50x squared. And we have the 25 minus x squared over 625 is equal to 0. So first we can just multiply both sides by 625, which will just leave us with the numerator here. And then I can set each one of these factors equal to 0. Now, remember that, let's take a look at the e function in our calculator real quick. So if I just go here and I just do e to the x, second e raised to the x, and let's do a standard zoom here. Notice that the y values approach 0, but they never actually equal to 0. So there's nothing in here for x that we could put to make this term equal 0, because 0 is not in the range of the e function there. So the only thing we have to worry about then is this factor there. So let's do that one. So 25 minus x squared is equal to 0, and we can factor that as 5 minus x times 5 plus x is equal to 0. And we're going to get x is equal to plus or minus 5. So those are our two reflection points. And then finally, we can just put them here. So we have a negative 5 and a positive 5. And we're going to check values. So for example, if we have something between negative 5 and positive 5, like a 0, we're going to get 25 minus 0. So that's going to be positive. So that's going to be concave up there. If we check values greater than 5 or less than negative 5 in there, we should end up getting negative, which means it's going to be concave down. Alright guys, if you have any questions at all, please let me know, and I hope you all have a great rest of your week. Thanks.